In this video, we're going to be talking about graphing. Before we actually start graphing things, we need to talk about the rules for graphing. The first rule, and you should know this from dry mix, is that the independent variable goes on the x-axis and the dependent variable goes on the y-axis. So remember, in dry mix, D stands for dependent variable, R stands for responding, and the Y stands for y-axis. In mix, the independent variable is the one you manipulate, and it goes on the x-axis. The graph needs to have a title. So a good title to use is the effect of the independent variable on the dependent variable, or you can simply call it the dependent variable versus the independent variable. Each axis should be labeled with the variable and units. So you shouldn't just say miles, you need to say distance in miles. Usually you will make a scatter plot, so not a bar graph, not a pie chart, not a line graph. So in a scatter plot you don't connect the dots. Last rule, you want to make your graph big enough to see, so make sure you're using the right scale. Here is an example of a bad graph. See if you can spot what makes this a bad graph. So the first thing that makes this a bad graph is that it has no title, so we have no idea what data this is displaying. The axes, which is the plural of axis, are not labeled. They're not labeled with what it is, and they don't have units. The last thing is the dots are connected. So again, normally in this class you will be making scatter plots and not line graphs. We're going to talk about the different kinds of graphs now. So the first ones I'll show you will be ones we won't normally do in this class. We won't be making pie charts too often. With a pie chart, the purpose is to show data that are parts of a whole. Specifically, it shows percentages. So this is a chart of gases in the atmosphere. So nitrogen is 78%. You can see that's a big whole hunk of this circle. Oxygen is 21%. And then you can see this little sliver that are other gases. So this graph is useful because it clearly shows you that most of the atmosphere is made up of nitrogen and oxygen. Another type of graph that we won't be doing too often is a bar graph, useful for comparing data of similar items or events. So this shows us favorite color and how many students like each color. So 15 students like blue, maybe looks like 10 or 11, 10 like green, etc. Line graphs, which we will be doing sometime in this class, are best for displaying data that changes, specifically where you want to see the change from point to point, and that's why you connect the dots. So this is a graph of temperatures in New York City, so how the temperatures change from day to day in Fahrenheit. So basically the lines are connected because you want to see if it goes up or down from day to day. So from this day to this day, it went up, but from this day to this day, it went down. From this way to this day to this day, it went up. That kind of thing. Scatter plots, which we will be doing most often in this class, are also for data that changes, but it's where you want to see the overall trend. So the dots do not connect. So basically, what is the overall trend here? Well, the overall trend is that the more years of experience that are had, the greater income is earned. And then it looks like if you start working a whole lot, your income is not going to go up a lot from year to year. Now, there is one thing missing in this graph. Can you spot what it is? Right, it's that the title is missing. So see if you can come up with a title for this graph. Pause the video if you have to. So I would call this graph the effect of years of experience on income. So basically, the years of experience is our independent variable, and the income is the dependent variable. Your income depends on how many years you have worked. All right, we're going to do a little bit of practice with graphing. So we want to make a pie chart of the following data. So this is data of color shirt worn and how many people were wearing that color shirt, the percentage. So first we have to come up with a title for this chart. So let's call it percentages of shirts worn. Now, 60% of people were wearing blue shirts. So this would be 50%. So we want 60% to be something like that. And then we want to label that with blue. Then 15% of people were wearing red shirts. So 15% is going to be something like that. Maybe a little bit smaller. So we'll label that with red. And then the chart, the part of the pie that is left over, is going to be 25% for green. So we may be looking at pie charts in this class, but we probably won't be making them. Alright, we want to make a bar graph of the following data. So this is data from my old school. I had my periods 1, 5, and 7 measure the distance between my room and what was room 208. So, first we want to come up with a title for this graph. So I'm going to call it distance to room 208 versus class period. So distance to room 208 is the dependent variable. Class period is the independent variable. So the distance measured depended on which class measured it. That makes sense. Okay, now we have to label our axes. So class period is the independent variable, goes on the y-axis. Distance in meters goes on the x-axis, the dependent variable. Okay, so now we have to number our axes. So I'm going to put the bar for class period 1 here, for 5 here, and for 7 here. And then I'm going to label these by 2s, so 2, 4, 6, 8, 10, 12. Okay, now class period 1 measured the distance to be 10.2. So that's going to be right around here. And then I actually have to draw my bar. Alright, class period 5 measured the distance to be 11. So that's going to be around here. So there's that. And I actually have to draw my bar. Then class period 7 measured it to be 10.8, which is going to be around here. And there's my bar graph. Now, like I was saying, this bar graph is useful because it shows us that all of the class periods measured pretty close to the same number, but that there is some variation. Okay, we're going to make a line graph of this data, time and distance from my house in miles. So here's our title, distance from my house versus time. And I probably should capitalize that, so that's something you can fix. Draw lines for our axes. Let's label our axes. So time in minutes is going to go on the x-axis. Distance in miles is going to go on the y-axis. Now let's number our axes. So here I'm going to go by 5s. 5, 10, 15, 20, 25, 30. And over here I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14. Okay, now we actually have to graph it. So at 10 minutes, I was 4 miles from my house. At 20 minutes, I was 11 miles from my house, so that's going to be around here. And at 30 minutes, I was 14 miles from my house. Now, since this is a line graph, we want to connect the dots. Now, I didn't have room on the slide to put 0, 0 here, so we're going to assume that at time 0, I was 0 miles from my house. So let's just put this spot in as an extra point, and then we can connect the dots. So again, we want a line graph for this because we want to see how it changes from point to point. So from 0 to 10 minutes, I was able to go a certain distance, and then from 10 to 20 minutes, I was able to go a bit further, and then it looks like I slowed down again from 20 to 30 minutes. Alright, here we're going to make a scatter plot. So this shows speeding tickets, so speed over the speed limit, and then traffic ticket cost. So speed over the speed limit is going to be our independent variable, and then traffic ticket cost will be our dependent variable. So cost in dollars depends on how fast you're going over the speed limit. So the first thing we have to do is come up with a title for our graph. So I'm going to call it the effect of speed on traffic ticket costs. Our x-axis label is going to be speed over the speed limit. Don't forget the units, miles per hour. Y-axis is going to be traffic ticket cost. Again, don't forget units, so dollars will be our units there. Draw in our axes, and then we have to number our axes. So on the x-axis, I'm going to go 10, 20, 30, and I'm going to skip a line in between so it's more spread out. Remember, one of the rules of graphing is to make your graph big enough. And then on the y-axis, I'm going to go up by 100ths. Alright, now I can actually plot my points. So when a person was going 10 miles over the speed limit, their traffic ticket cost $100. When someone was going 25 miles over the speed limit, so 25 is going to be right here, they had to pay $300. And when someone was going 32 miles over the speed limit, they had to pay $650. So 32 is going to be right around here, and then 650 is going to be around here. So again, this is a scatter plot, so we don't want to connect the dots. We want to see the overall trend. So the overall trend looks like that the faster you go, the more the ticket cost increases. So not only, obviously, the more you're going over the speed limit, the more the traffic ticket will cost, but it looks like as the speed increases, you'll have to pay more and more and more. So if you look at the difference between going 25 and 32, that's a really big difference. That's a bigger difference than between 25 and 10. I hope you know a bit more about graphing now. In your Cornell notes, do not forget to write your